Hello, this lesson is going to be on multiplying fractions, and let's take a look at what we're going to be learning today. So today we are going to be learning about multiplying fractions. So at the end of this packet, you will be able to multiply fractions, cancel when multiplying fractions, multiply fractions and whole numbers, multiply mixed numbers, round and estimate when multiplying with fractions, and then finally be able to apply your multiplication skills with word problems and fractions. So here's something just to keep in mind a little bit here. Let's take a look at this. So when multiplying fractions, you are finding a part of a part. So for example, before you were multiplying like 2 times 3, that would give you 6, right? You'd end up with an answer that was more than you started with. Now, when you're multiplying fractions, that's not the case. You're going to end up with an answer that's smaller than the two numbers you're multiplying together. So, for example, if you multiply, say, 4/8 times 1/2, you're going to get an answer that's smaller than either 4/8 or smaller than 1/2. Why is that? Because multiplying 4/8, and I'll just write that out here, if you're multiplying 4/8 times 1/2, that's the same as saying I want to take half of 4/8. So if you think about that, what's half of 4/8? Right, it's half of that, so that would be 2/8, right? So really your answer then is going to be 2/8, or if you reduce that down, you would get 1/4. So half of 4/8 is going to be smaller than either 4/8 or 1/2. So I just wanted you to kind of keep that in mind with fractions, and you're wondering, well, why is my answer smaller than the other two fractions? Well, that's why, because you're taking part of a part. So let's go and open up our document here, and let's take a look at some problems to see how this works. So you can go ahead and read that. It's basically what I just was explaining there, but you can go ahead and read that. It would be good later. Multiplying and reducing. So let's start with row 1, and let's see, how do we multiply with fractions? So we have this first one here, I'll circle it, 2/3 times 4/5. So you're going to find that multiplying fractions is actually a lot easier than adding or subtracting fractions, because the bottom numbers, the denominators, do not have to be the same with multiplying fractions or with dividing fractions, which is the next packet. But you don't have to worry about getting that common denominator. So all you do when you do this is you multiply the top. So we have 2 times 4. I'm going to have to erase my little circle here so I can have a little bit of space here to work. 2 times 4 on top. 2 times 4 on top, the two numbers that are on both the tops of the fractions, and 3 times 5 on the bottom. And I'm going to make a little bit of space, white space here, so that we can have something to draw with. So 2 times 4 then is 8, right? 2 times 4 is 8, and 3 times 5 is 15. So the answer is 8/15. So keep in mind, though, there'll be times when you get down the line a little bit in this packet where you're going to have to be reducing fractions. So right now we're not reducing anything. 8/15 is the final answer. We have an even on top and an odd on the bottom. Okay, let's look at the next one. Actually, I'm going to skip to the next one over here because we don't have to do the whole row. I want to get to some of the harder ones, but let's try this one. 1/8 times 7/10. So I'm just going to rewrite it down here so we have a little more space here to draw and not crunch. 1/8 times 7/10. So you simply just multiply the top numbers together. 1 times 7 on top, and 8 times 10. You probably already have it figured out because it takes me a little longer to write it on the computer than it does probably for you to mentally process that. So 1 times 7 is exactly 7. And 8 times 10 is 80. And we cannot reduce this fraction any further. We have an odd on top and an even on the bottom. And 3 does not divide into either one of those numbers. So that answer is 7/80. I think we're ready to try a few harder problems. So let's clear everything. And I want to go to let's look at row 4. So let's slide down to row 4. Now we have 3 fractions at once. And I'm going to make a little bit of white space again. So it's the same thing with 3 fractions at once. The only thing is you have to multiply the 2 together first and then times that answer by the third one. So for instance, we have 3/5. So that's going to be, I'm going to just rewrite it all. Whoops, I'm just going to erase that. Make a straight line. I didn't want to do that. So I want to do a straight line across the top. So we have 3 times 1 times 3, right? That's the top numbers. Those are our numerators in our fraction. And on the bottom, we have 5 times, you got it, 2 times 4. And then it's just a matter of multiplying everything together. So that will give us, on the top, we have 3 times 1, that's 3, times another 3, that's 9. So 9 is on the top. And on the bottom, then, we have 5 times 2, that's 10, times another 4. So 10 times 4, or 40. And think about it, can that be reduced at all? You have an odd on top and even on the bottom. 9 will be divided by 3, but 40 will not divide by 3. Not that I can tell. Nope. So that is as far as you can go. So 9/40 is the answer to that problem. So you do the same thing when you have 3 fractions. Multiply the top numbers, multiply the bottom numbers. Okay, let's move on a little bit from there. I want to go to the next page. Canceling. This is a super important thing to learn how to do, because when you cancel, you don't have to go later when you get an answer and reduce your answer. So let's see how this works, for example. So let's look at the first one here. So we have 2 times 5, or 2/5 times 3/4. So we can see that you can cancel a 2 and a 4. What that means is that you can divide the same number into the top and the bottom. So I know that I can divide a 2 into the 4, right? If I divide 2 into 4, 4 divided by 2 is 2, right? But I also can divide that same 2 by this 2. So 2 divided by 2 is 1. So I was able to cancel out the 2 and the 4. And now when I multiply across the top, I'm multiplying 1 times 3 instead of 2 times 3. And on the bottom, I'm multiplying 5 times 2 instead of 5 times 4. And that answer will give me 3 on top and 10 on the bottom. I'm in lowest terms. Let's see what would happen if I were to multiply that without canceling. So my original equation was 2 times 3 on top, right? 2/5 times 3/4. I'll just rewrite it like this, just like the original problem. And this was 4s. That would give me 2 times 3 on top, or 6. 5 times 4 on the bottom, or 20. And now I see that I'm not in lowest terms. So now I do have to reduce. So I know that I can take a 2 into both a 6 and a 20. And if I do that, I would get 3/10, right? And that's what we got when we canceled. We just had one less step to do because we canceled those numbers out. And a lot of times when you get bigger answers, it's actually better to be able to cancel first than try to figure out what numbers will divide into the top and the bottom the same. So let's try another one with canceling. Let's go to this one right here. And let's take a look at what can be canceled. Well, I can know that a 5 and a 10, those two are factors of each other. So I can divide a 5 into 10, and I can get 2. 10 divided by 5 is 2. And if I divide 5 into itself, because remember, it's got to be the same number, I get 1. And now if I multiply across the top, I get 1 times 7, or 7. And on the bottom, I get 8 times 2, or 16. And now I'm already in lowest terms. Had I not canceled, I would get a bigger fraction that would then need reducing a lot, just like the one we did down here would need reducing. So the canceling is very helpful. Let's see how that works. A few bit harder problems. So let's go on to row 4 and see what happens now. So let's put a blank space for us down here at the bottom, right here. Okay, so now if I'm looking at this, adjust this a little bit here. Okay, if I'm looking at this first problem here, I've got 15 16ths times 12 25ths, correct? Well, I know that I can divide 15 and 25, both can be divided by 5, right? So 15 divided by 5 is 3, and 25 divided by 5 is 5, right? Okay, and then I also, supposed to be a 5, make a better 5. I also know that 16 and 12, that I can divide a 4 into 12 and a 4 into 16. So if I divide 12 by 4, I get 3. And if I divide 16 by 4, I get 4, right? So now my answer is going to be 3 times, my mouse isn't cooperating here, 3 times 3 on the top. And I want to fix that 3 because that's messy. Make sure you can see that's a 3 here. 3 times 3 on the top, and 4 times 5 on the bottom, which gives you 9. And what's on the bottom? 20ths, right? And that's as low as that fraction will reduce to, because we canceled before we multiplied. So 9/20. I could have taken 15 times 12 on top and 16 times 25 on the bottom first without canceling. I would have got a really big number, and I would have had to do a lot of more multiplying. And then I would have had to go in and reduce the top number and the bottom number as well. And I would have ended up eventually with 9/20, but there's a lot more steps in that. So if you can cancel, definitely utilize that. So let's look at the next one, 7/24 times 32 35ths. So I know that 7 will go into 35 how many times? 5 times, right? I'm going to actually change colors here so we can. So 5 times 7 is 35. So 35 divided by 7 is 5. And 7 divided by itself is 1. What about 24 and 32? Well, I know that 4 times 8 is 32, and 4 times 6 is 24. So why don't I divide 4 into both? 32 divided by 4 is 8, and 24 divided by 4 is 6. Now notice something. I could have taken a bigger number, couldn't I? I could have taken 8. So I didn't notice that at first. So look what you can do. This is a good example. Even if you don't notice the bigger number at first, I know that I can take a 2 into the 8 and the 6. So now I can further divide. 8 divided by 2 is 4, and 6 divided by 2 is 3. So look at that. Now I should be able to get an answer in lowest terms. 1 on top times 4 on the bottom, and 4 on the top, 1 times 4 on the top, and on the bottom I would get 3 times 5, right? And so that would become 4 on the top, like I was trying to get at there, 4 on the top, and then on the bottom I would have 3 times 5, 15. So 4/15 is now in lowest terms. I do not have to reduce any further than that. So canceling is definitely helpful for being able to multiply without having such huge numbers. So I encourage you at home to give that a try. Let's go on to the next set here. There's also an example in your packet of how to do the canceling if you want more detail on that. Let's go on to row 10. So here we have three numbers being multiplied, or three fractions being multiplied together. Let's look at number 10, the very first one. So we've got an 8/21, a 1/3, and a 15/32. So now I could multiply across the top 8 times 1 times 15, and then across the bottom 21 times 3 times 32, but I'm doing a lot of number crunching, and if I can cancel, I'm going to do that because it will help me to not have to do so much number crunching. So I know that 4 times 8 is 32, so I'm going to divide 32 by 8. 32 divided by 8 is going to give me 4, and 8 divided by 8 is going to give me 1. See anything else I can do? Sure, I can divide 3 into 15, right? So 15 divided by 3 is going to give me a 5, and 3 divided by 3 is going to give me a 1. Is there anything else I can divide? I have a 1, a 1, and a 5, a 21, a 1, and a 4. No, right? So now I'm left with 1 times 1 times 5 on top. And on the bottom, I'm left with 21 times 1, 21 times 1 times 4, right? So we got to do our multiplication. The answer then is 5 on top, 1 times 1 times 5. And on the bottom, 21 times 4, that's going to be 84. 20, 40, 60, 84. Yeah. And that's as low as we can go. We have an odd on top and an even on the bottom. 3 does not divide into either one. So that is our answer. So that's another look at canceling with 3 fractions instead of just 2. We'll try one more together. Let's do the one on the end here. So we have 19/36, 7/10, and 3/7. So what can we cancel? Let's take a look. Well, I know that I can divide 36 by 3, right? 3 goes into 36 12 times. 3 goes into itself 1 time. And then I see that I have 2 7s. Those are the easiest. 7 divided by 7 is 1. 7 divided by 7 is 1. Anything else that I can do? No. So now I have 19 times 1 times 1, which is going to give me 19 on top. And then on the bottom, I'm going to get 12 times 10 times 1, or 120. So that's my answer. So use canceling. It's going to definitely be of help to you. Let's move on to page 42. And let's take a look at row 1 here. This one is multiplying fractions with whole numbers. So now there's one extra step when you're multiplying by a whole number. I'll put myself back up here so we're out of the way. Let's put some white space for us here. Okay, so 4 times 3/7. There's just an extra little step. We have to first change our whole number into a fraction. So we're going to change 4 into 4 over 1. So isn't 4 over the 1 the same thing as 4? Exactly. So anytime you have a whole number, you just put it over 1, and then you multiply by the second fraction. And it's the same way as it was with multiplying any fraction. So 4 times 3 on top is 12. And 1 times 7 on the bottom is 7. But now look what we've got. We have an improper fraction. It's improper because the top number is bigger than the bottom number. So we have to do a little division, a long division, and you might be able to do this in your head. I'm practicing with fractions for a bit now with a couple of different packets. So feel free to do that if you know what's going on. Otherwise, I'm going to show you how to do it with long division. 12 on the inside, 7 on the outside. So I say, how many 7s can go into 12 without going over? That would be 1, right? If I do 2 times 7, that's 14, and that's over. So just 7 times 1 is 7. And then I take 12 minus 7, and I get 5. And I take that remainder 5, and I bring it up to the top. And it becomes 5 on top and 7ths on the bottom. So the real answer then is 1 5/7. So we realize when you're going to be multiplying by a whole number now, you're going to start having to do that extra step of division to get a mixed number as your answer. So let's look at the one on the end here, right here, 3 times 4/5. And let's do that one together. So first thing I'm going to do is put 3 over a 1. And then I just multiply across the top, and I get 3 times 4 is 12. And on the bottom, I get 1 times 5 is 5. So this is very similar to the one we just did. We have to divide. This time we're dividing the 12. It's top numbers on the inside, bottom numbers on the outside. We're dividing 12 by 5 this time instead of 7. How many 5s go into 12 without going over? 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 15 is over, so it has to be a 2. So 2 times 5 is 10. 12 minus 10 is 2. Take the remainder 2, bring it back up to the top, and make it the numerator of the fraction, and the denominator will be fifths. So the answer is 2 2/5. Feel free to pause the video if needed, or go back and take a look at this again if you need to. I'm going to move on to a few harder ones now. Let's try row 4. So if we look at row 4, let's do the first one. And we have 35. So we are going to change, I gotta change my color back here. We are going to change the 35 to 35 over 1. And we're going to multiply the top numerators, 35 times 7, and the bottom, 1 times 30. However, I noticed that I can do a little bit of canceling before I even multiply. So I know that I can divide 35 by 5, because 5 times 7 is 35. And I know that I can divide 5 into 30. 30 divided by 5 is 6, because 5 times 6 is 30. And now I can get my answer, 7 times 7 on top, 49. And on the bottom, I get 1 times 6, or 6. And now I have to do my step of dividing. What number goes on the inside of my division house? Exactly, my 49, the top number. And I divide, the outside number will be a 6. How many 6 go into 49 without going over? 7. 6 times, well, no, 8. 6 times 8 is 48, right? So 8. 6 times 8 is 48. And 49 minus 48 is 1. I bring my 1 back up to the top, and I get 8 and 1. What's the bottom number? 6. 8 and 1/6. So go ahead and give those a try at home. We will move on now to page 43. I'll clear that. Look at page 43. Multiplying mixed numbers. So now we're going to have a mixed number, not just a whole number without a fraction. Now it'll be a whole number with a fraction. So let's take a look at how you do this. Very, very similar. So we have 1 1/2 times 1/4, the very first one there in row 1. So what do we do first? Well, first we have to change our mixed number to an improper fraction. So do you remember how you do that? You take the whole number, let me just make our spotlight here. Take the whole number times the bottom and add the top. So 1 times 2, that's 2, plus the top, 3. So that mixed number becomes 3, oops, need the right color here. That mixed number becomes 3 halves. right? Because 3/2 is the same thing as 1 1/2. And then times 1/4, and we just divide, or I mean, we just multiply across. So 3 times 1 is 3, 2 times 4 is 8. So that answer is 3/8. It's a proper fraction. We don't have to divide anything at this point because it's good. It's good. Okay, let's try the one on the end here. 3/10 times 5 1/2. Well, the 3/10 is going to stay 3/10. And I have to change 5 1/2 to an improper fraction. So I take the whole number 5 times the bottom. 5 times 2, that's 10. Add the top, that's 11. So it's going to be 11 over 2. And now, is there anything I can cancel? No. So I just multiply across the top. 3 times 11 is 33. I don't know why my 3's aren't working out too well. And my bottom is 10 times 2, or 20. And now I have an improper fraction, so now I do have to divide. So now I'm going to make my division symbol, and the number that goes on the inside is the top number, 33. And I'm going to divide the bottom number by that. How many 20s will go into 33? Only one, because 20 times 1 is 20. 20 times 2 is 40. That's over. So I do this, and then I subtract. 33 minus 20 is going to give me 13. And that 13 is going to come up to the top and become the numerator of my answer. And the denominator is going to stay 20th. Try to fit that all in. So my final answer is 1 13/20. Okay, let's clear our drawings. Let's go on to, let's see if there's any harder ones here. Let's try just number 4 here. This one right here. Let's try that one. Make some white space so we have a little bit of room here. Let's draw this over it so we can have some room there. Okay, so how are we going to do this? We're going to take 3 3/4 and make it an improper fraction. So it's going to be the whole number, 3 times the bottom, 4, that's 12, plus 3 more. 15/4 is the first one that we're multiplying, times 8 9s, that's going to stay 8 9s, not a problem there. And then we have 1 1/5. We have to change that to an improper fraction. So whole number times the bottom. 1 times 5 is 5, plus the top is 1 more, 6. So 6/5. And now we could multiply across the top, or we can notice there's some canceling that we can do. So let's do some of the canceling so we have less work to do later. So I know that 15 and 5 will divide, right? So 15 divided by 5 is going to give me 3. 5 divided by itself is going to give me 1. I know that 8 and 4 are going to work. 8 divided by 4 is going to give me 2. 4 divided by 4 is going to give me 1. And I know that I can divide 6 and 9 by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. Now look at how nice that is. Way less multiplying. Super easy now. It's just 3 times 2 times 2 on top. So 3 times 2 is 6. 6 times another 2 is 12, right? And on the bottom we get 1 times 3 times 1. That's just 3. And now look how easy that is. 12 on top is really 12. You probably already know the answer, but let's just show you. This is 12 on the inside and 3 on the outside. And how many 3's go into 12? Well, exactly 4. So your answer then is the whole number 4 in this one. So 4 is your, oops, didn't want to do that. 4 is your answer right there. So you can have a whole number for an answer. Why not, right? Okay, that's a good example of using canceling as well. All right, let's go on to rounding and estimating. So now remember back in one of the packets, I think it was the addition packet, we had to decide if something was 1/2, less than 1/2, or more than 1/2. We're going to do the same kind of thing with multiplying now. So if we look at the first problem, right here, 6 times 2 3/4, we have to estimate. So it says first round each mixed number to the nearest whole number, and next find the product of the rounded numbers, then find the exact answer. So we got to do a bunch of things for these. So we look at the 2 3/4. We know the 6 is going to be a 6. There's nothing more to round to a whole number. It's already a whole number. But 2 3/4, we have to decide if the 3/4 is half, more than half, or less than half. Well, half would be 2/4, right? Because half of 4 is 2. So 3/4 is going to be more than half. So we know that if we were to round this, if we're rounding more than half, we're going to round the 2 up to a 3, right? So we're going to round it to a whole number. It's really going to be approximately 18, right? Now they want us to find the exact answer. So the exact answer is going to be close to 18. So we're going to get 6 on the bottom here over 1 times, not on the bottom, on the top. Oh, times 2 3/4. We're going to change that to improper fractions. So whole number 2 times the bottom 4, that's 8, plus 3 more, that's 11. 11/4. And then before we multiply across, can we cancel? And yes, we can. We are going to cancel a 2 out of the 6. That'll leave us with 3. Put a 2 into the 4. That'll give us 2 here. And then when we multiply across the top, we get 3 times 11 is 33. And on the bottom, we get 1 times 2, or 2. And then we have to do our division, which now maybe you're getting really good and you can just do it in your head, but let's just show how to do all of this. So how many 2's are going to go into 33? Well, first we'll say how many 2's will go into the first 3. Only 1, right? 2 times 1 is 2. And we say 3 minus 2 is 1. We're going to bring down our 3. How many 2's go into 13? 6. 2 times 6 is 12. 13 minus 12 is 1. That's our remainder. That comes up to the top, becomes the numerator of our fraction. The denominator stays a 2. So the answer to that problem is 16 1/2. So we were close with 18. 16 1/2 is the exact answer. So you're going to have to find the rounded one and the exact answer on these problems. Let's look at just the second one here. 3 1/8 times 4. Is 1/8 less than a half, equal to a half, or more than a half? Right, it's less than a half. 4/8 would be half. So we're going to keep this rounded down to 3, and then we're going to multiply that by 4, and we're going to get 12, right? So then we would find the exact answer the same way we just found the exact answer for the first one, and then we would compare. So I'll let you try those at home. Let's go on to, if you just go down to row 4, we'll just try this one here. 2 1/4 times 2 2/3. So first we round. 2 1/4 is closest to 2. 2 2/3, however, is closer to 3. So we would get 6. Why is it closer to 3? Because 2/3 is more than half. And then to find the exact answer, we have to have an improper fraction. So 2 times 4 is 8, plus 1 is 9. So we get 9/4 times 2 2/3 has to be changed to improper fraction. We get 2 times 3 is 6, plus 2 is 8. And thirds on the bottom. And I see there is a little bit of canceling that can happen, which is good. So we're going to go ahead and do that. So 9 divided by 3 is going to be 3. And 3 divided by itself is going to be 1. 8 divided by 4 is going to be 2. 4 divided by itself is going to be 1. And I'm left with, on the top, 3 times 2, or 6. And on the bottom, 1 times 1 is 1. So 6 over 1 is really 6. So look at that. We are exactly right. This one turned out, our estimate was the exact answer to the problem. Okay, let's go on to page 45, applying our multiplication skills now. So we're going to do a couple problems. Let's take a look at number 7 here. And on number 7, it says Robert works as an apprentice electrician. He makes $15 an hour. Use estimation to decide which of the following is closest to the amount Robert makes for 3 1/4 hours of work. So we know we're going to be multiplying, and we're going to be using estimation. So we are going to be multiplying his $15 an hour times his hours of work, which is 3 1/4. But now they want us to estimate, so we're going to take a look at the 1/4 and decide if that is more than half, less than half, or exactly half. Well, we realize that it's less than half because 2/4 would be exactly half. So we're going to keep it rounded down to 3, and we're going to keep the 15 here. And we're going to say we now have 15 times 3. So that is going to be 45, right? Now don't be tricked. You got a choice of A or B here. We know that this one's out, right? So taking a look at A and B, now we have to say, well, it's really, the real answer is going to be 15 times 3 and some other bit, a little bit more, right? So we know it's going to be a little bit over $45, right? It's not going to be under $45. So our correct answer then is letter B right here, 45, a little over $45. Okay, let's take a look at another set here on the next page, number 11, 12, 13, 14, and 15. I don't know if I'll do all these, but let's take a look. In the weeks before Christmas, Serena worked 11.5 hours each day in a department store. For the first 8 hours each day, Serena makes $6.40 an hour. How much did she earn for those 8 hours? Well, that is just multiplying her wage, $6.40. Who makes $6.40 anymore, right? $6.40 for the first 8 hours, right here. So we're going to multiply that together. The first 8 hours, she makes $6.40. How much did she earn in those 8 hours? Well, we multiply. 8 times 0 is 0. 4 times 8 is 32. Carry the 3. 6 times 8 is 48. 49, 50, 51. So she made $51.32. That's a 2 or 20 cents. $51.20. That's how much she made for 8 hours of pay. Number 12. For overtime work, Serena gets 1.5 times her regular wage. What does she get for 1 hour of working overtime? Well, that's multiplying 1.5 times $6.40. Or you could say it's $6.40 plus half more of $6.40. So a couple ways of doing this. We're going to use fractions because this is what our packet's on. We change the first fraction to an improper fraction. Whole number times the bottom. 1 times 2 is 2 plus the top is 3. So we get 3 halves for our improper fraction. And we're going to times that by $6.40, and we're going to put that over 1. Just like that. I can cancel, even though it doesn't look like I can, maybe initially. I can divide 2 into $6.40. If I divide 2 into 6, I get 3. If I divide 2 into 4, I get 2, and 2 into nothing is 0. So half of $6.40 is $3.20. 2 divided by itself is going to be 1. So it's going to be $3.20 times 3 for the answer to that problem. So let's do that real quick here on our screen. $3.20 on the top times 3, and then on the bottom it's just 1, right? So it's just going to be a whole number. So we get 0 times 3 is 0, 2 times 3 is 6, and 3 times 3 is 9. She makes $9.60 an hour for overtime. And that's the same as saying she makes $6.40 plus half more of that, which would be $3.20. So that comes out to $9.60. How many hours of overtime did Serena work each day? So she works 11.5 hours each day if you go back up to number 11 in the problem there. So 8 of them is considered regular pay. So how much is that going to be overtime? Well, you could do subtraction. You could do 11.5 hours. You can probably just do it in your head, but if you don't see that right away, you're going to subtract the 8 hours of regular pay she gets. And when you subtract, you're going to borrow from this. It's going to become a 10. You're going to bring 1 over, which is going to then make this 3 halves, right? Because 2 over 2 plus 1 half is 3 halves. Oh, wait, I don't have to do that. Hang on a minute. I don't have to borrow anything. Never mind, never mind. Let's go back to this. So I didn't mess you up on that one. So I don't have to worry about it because I have a half on the top. So 1/2 minus nothing is just 1/2. For some reason I was thinking that I had to do the other way around. And then 11 minus 8, 3, right? So you could probably have figured that out in your head anyway. So 3.5 hours of overtime. So how many hours of overtime did she work? 3.5. Here's your answer. How much does Serena make each day for overtime work? Well, now you're taking 3.5 and you are timesing it by her wage for overtime, which we figured out over here was $9.60. So that's going to be times $9.60 over 1. Just like that. And remember to change 3.5 to an improper fraction, so that becomes 7 halves. 7 over 2 times 960 over 1, 9.60. And we know that we can put a 2 into 9.60, right? We can cancel a few things, so we're going to do that. So let's go back through and cancel. 2 goes into 9 4 times. That would give us 8. 9 from 8 is 1. Bring down 6. That's 16. 2 into 16 goes 8 times, and then we're left with a 0. So $4.80. If you need to do the long division for that, go right ahead and do that to prove to yourself that it's really going to be 960. So yeah, that's right. Okay, so then this becomes a 1. And then we multiply 480 times 7. And that would be our answer. So $4.80 times 7. And the reason why we don't have anything on the bottom is they're just ones, right? So we don't have to worry about those. And we multiply like that. So you can go ahead and do that multiplication. That would be the answer to 14. And then number 15, it says find Serena's total income for an 11.5-hour day. So you have to add up her regular pay and her overtime pay, which is what you're figuring out for number 14. So that's a long one, but it was a good one to work through with you. So let's clear, and I believe that's close to the end of the packet. In fact, that is the end of the packet. So I'm going to stop my sharing here, and we will see you for the next video. So good luck, and happy studying.